Okay, so today we're going to talk about grams to grams stoichiometry. And we're going to work these types of problems. And before we do that, and this is the guided notes you should have, grams to grams problems. Now, before we do that, we need to review. Remember, when we're converting, anytime we're converting moles to grams, we need to multiply by the molar mass. Anytime we're converting grams to moles, we divide the grams by the molar mass to convert. And we'll have to do that in these problems. We'll have to convert moles to grams, and we'll have to take grams, convert to moles. Now, basically, stoichiometry, what it is the way of measuring elements. I can, if I know the amount I start with of a reactant, like in this reaction right here, it says that 2 moles of sodium reacts with 1 mole of chlorine gas to produce 2 moles of NaCl. This is the smallest whole number ratio of how these elements combine based on moles. You know, it's a 2, 1, 2 ratio. If I change these numbers, if I say, well, I have 4 moles of Na, how many moles of Cl2 would react? Well, it would be 2 moles. How many moles of NaCl would be produced? It's a 2-2 ratio, same thing as 1 to 1, same thing as a 4 to 4. If this number was 8 moles of Na reacts with 4 moles of Cl2 to produce 8 moles of NaCl. So this is based on moles. I can use this like a recipe. That's what the balanced equation is. It's a recipe, but I don't always want to produce 2 moles of NaCl. If I wanted 2 moles of NaCl, I would know I need 2 moles of Na. I need to weigh out 2 moles of Na reacted with 1 mole of Cl2. But, you know, sometimes maybe it's if I have 0.5 moles instead of Na, then those numbers would change. 2 to 1 ratio, 0.5 to 0.25, and then be 0.5. So I can use my balanced equation to figure out things. And we've already talked about how to go from moles of one substance to moles of another using these numbers by setting up a proportion. You know, if I have 0.5 moles of Na, and I want to know how many moles of NaCl can be produced, well, I just set up a proportion. 2 over 0.5 equals 2 over x, cross multiply, solve for x, and I get my moles of, NaCl. So that's a one-step problem. And then we took it a step further and come up with two-step problems and say, well, if I have, 0.5 moles of Na, how many grams of NaCl will be produced? In that case, we just went from moles of Na to moles of NaCl using the balanced equation, and then multiplied by the molar mass to get the grams. Well, today we're going to be, the problems we're going to do today is like this. It's going to say, well, how about if you have 10 grams of Na? Because remember, in the lab, we weigh things out with a balance in grams. We don't have a balance that weighs things out in moles. That's why we have to convert moles to grams or grams to moles in these problems. Let's say I had 10 grams of Na, and I want to know how many grams of NaCl could be produced. There is no way that I can go directly from grams of one substance to grams of another substance. It's not a one-step problem. Instead, I have to kind of take a detour. I have to go down here, and my first step would be to convert to moles of Na by multiplying by the molar mass. Then once I'm in moles of Na, I can go to moles of NaCl by using the balanced equation and setting up a proportion. Once I'm in moles of NaCl, then I can simply actually, over here I made a mistake. When I said multiply by molar mass, I would divide by the molar mass to get moles. And then when I'm going, and that's my first step in the problem. My second step would be to go moles of Na to moles of NaCl. And then my third step, I just need to convert from moles of NaCl to grams, so I would multiply by the molar mass. So if you notice, step 1 and step 3 is what we did in the last unit. It's just converting moles to grams and grams to moles. Step 2 is the only new step, and that's when we use the balanced equation to go from moles of one substance to moles of another substance. So these are going to be 3-step problems. Alright, so grams to gram stoichiometry, you need to remember, it's 3 steps. First step is convert grams to moles of what you're given, so you divide by the molar mass. Step 2, convert moles of the starting substance into moles of your new chemical that you want by using the balanced equation. You use the coefficients. That's the only step to where you use coefficients. And then the last step is once you're in the moles of your new substance, convert that to grams by multiplying by the molar mass. So let's look at some examples. So if you look at your practice problems, or your notes, the first page, it's just the same thing as this right here. You're writing on this right here, but I have, where I can have more room, I put these problems, on a slide here by themselves. So starting with the first problem, it says I have 68 grams of H2. That's what I'm starting with. So that's what I'm given in the problem, my starting substance. How many grams of O2 are produced? And actually, it should say, let me look at that problem. It should say how many grams of O2 reacted with it, because O2 is not a product. But, no matter, regardless of how it's worded, it still asks you to go from grams of H2. It's saying you have, 68 grams of this stuff. How many grams of O2 are needed to react with it? Alright, so I'm going to do this in steps. My first step, I'm in grams. I cannot go from grams of H2 to grams of O2. I cannot do it in just one step. I have to do it in different steps. My first step, I need to be in moles of H2. So I'm going to convert grams of H2 to moles. So I take 68 grams of H2. I'm going to divide it by the molar mass of H2. Molar mass. And remember, I'm not using these coefficients on steps 1 and 3. These coefficients are only used in step 2. I'm just looking for the molar mass of H2. Now H is 1.01, so I have 2 atoms of it, so the molar mass is going to be 2.02. And I need to round everything to 2 decimal places. I'm going to bring in my calculator. I have 68 divided by 2.02. It's going to give me 33.66. Now I'm in moles of H2. So all I did the first step is convert grams to moles, something we've been doing for over a month. Alright, so my next step is to go from moles of H2 to moles of what I'm looking for. What I want is grams of O2, but I got to find moles first. So I'm going to go moles of H2 to moles of O2. I use my balanced equation. The coefficient for H2 is 2. I put that 2 over 33.66 equals the coefficient in front of O2 is 1. So that will be 1 over X. And X is going to give me moles of O2 that can be produced from 33.66 moles. So I know when I have 2 moles of H2, I get 1 mole of O2. That's why I have the 2 and 1 on top. But I don't have 2 moles, I got 33.66. And how many moles of O2 can be produced from that? So I'm going to cross multiply. That's going to give me 2x equals 33.66. Divide both sides by 2. And I'm going to get 16.83. So I get 16.83, and that's going to be moles of O2. And then my last step, I'm in moles of O2, but I need grams. If it just asked me for moles, I could have stopped. But it asked me for grams, so I'm going to 16.83, I'm going to multiply by the molar mass of O2. Oxygen, one oxygen atom would be 16.00, but I have two of them, atoms, so that would be 32.00. And equals 538.56 grams of O2. So basically this problem is saying if I have 68 grams of H2, how many grams of O2 react with it? Well, it'd be 538.56 grams. So three-step problem. I only use my coefficients to convert in step 2. Step 1 and 3 is just like what we did in the last unit, in unit 6. Alright, so my next problem says, given, and it's the same equation here, it's saying I'm given 2 grams of O2, so it's saying I have, 2 grams of this. How many grams of H2 are produced? Well, H2 should say reacted with it, because H2 is not a product, but it's wanting to know how many grams of this is produced. So it's a grams to grams problem. It's going to be 3 steps. My first step is I take my given, what I'm given in it, I'm given 2 grams of O2, convert that to moles. I need that in moles. So O2's molar mass, again, one oxygen is 16.00, but O2 would be 32.00. So 2 divided by 32 equals 0.063. 0.063. And all I did is convert grams to moles. Now I'm in moles. Now I can go from moles of O2 to moles of H2. Because I eventually want grams, but I got to go to moles first. The way I did that, for O2, the coefficient for O2 is a 1, so I put 1 over how many moles I actually have, which is 0.063, equals, I'm going to moles of O2, so the coefficient for our H2 is a 2, so I put 2 over X. And then I'm going to cross multiply, and I get 1X equals 0.126. Divide both sides by 1, and my X is 0.126, and now I'm in moles of what I want, which is the H2. Now my third step is simply to take my moles and convert it to grams. 0.126 times the molar mass of just H2. H is 1.01. There's 2 of those, so it'll be 2.02. And my answer is going to be 0.25 grams of H2. So 3-step problem. Steps 1 and 2, stuff we've already done from Unit 6, been doing it for a long time. Step 2 is the only new thing that we've introduced in this unit. Now, what on the very first page of this, if you go back, it tells you what we're doing, the steps by steps from grams to grams stoichiometry. Now, if somebody would write this on the board, on my big whiteboard, write these steps on there, and you can leave them on there. That way you know how to work these problems. Remember, if we're working just moles to moles problems, moles to moles, you only got to do step 2. if you're starting off in grams and asked to find moles, you do steps 1 and 2. If you're starting off in moles and asked to find grams, you do steps 2 and 3. Or if it's a grams to grams, you do all 3 steps. Someone can write that on the board, and you'll have it there. Everybody can see what to do. Back to the example problems. My next one, given 8.35 grams of H2, how many grams of H2O are produced? All right, again, work this the same way. My first step, I'm taking what I'm given. I got 8.35 grams of H2. I need to convert that to moles by dividing by the molar mass of H2. So 8.35 divided by the molar mass of H2 is 2.02. And I get 4.13. And that's going to be moles of H2. My next step, go from moles of H2 to moles of H2O. It's a 2-to-2 ratio. So I will put 2 over, because that's what the coefficient for H2 is, 2 over how many moles I actually have, which is 4.13, equals, and then I'm going to H2O, so I put 2 over X, and I get 2x is equal to 8.27. Divide both sides by 2. 4.14. And that's going to be moles of H2O. And then my third step is just going to be to convert moles of H2O to grams. So I take 4.14, multiply it by the molar mass of H2O. If you add up the molar mass of H2O, hydrogen and oxygen, we know I do molar mass, you have to add these up. The molar mass is 18.02. And I'm just, still adding it up. I already know these, so it's, it's a little bit less time. I'm working these problems. 4.14 times 18.02 gives you 74.60. And that's going to be grams of H2O. So theoretically, before I ever do this experiment, if I knew I have 8.35 grams of H2, I can predict that I should get 74.6 grams of H2O from that, if I have that amount of the starting reactant of H2. This is the theoretical yield, all right? This is in theory. I'm doing this on paper. If I go into the lab and do this, I'm probably not going to get this amount because of human error, and we'll talk about what that means in a few days. Right now, we're doing all this on paper. This is all in theory. It's called a theoretical yield. All right, so my next problem is given 0.94 grams of H2, how many grams of O2 are produced? Or many should be say how many are reacted. So I'm looking for grams of O2. My first step, I can't work in grams, I need moles, so I got 0.94 grams of H2. I need to convert that to moles. I divide by the molar mass of H2. Hydrogen's 1.01, the atomic mass, there's 2 of them, so it'll be 2.02. Now 4 divided by 2.02, and I get 0.47 And all I've done is convert that to moles, so that'd be moles of H2. My second step is to go from moles of H2 to moles of O2. I use my Bounce equation. The coefficient in front of H2 is 2, so I put 2 over 0.47 equals, I'm going to grams of O2, so I use the coefficient for O2, which is 1 over X. And X is giving me the moles of O2 that reacted with 0.47 moles of H2. Now divide both sides by 2, and my X is going to be 0.24, and that's going to be moles of O2. My last step is going to be simply to convert to grams. I take 0.24, I'm in moles of O2, I need the molar mass of O2, which is 32.00. I get 7.68. And that will be grams of O2. Now we're going to look at one more problem. If you look at number 4 on the practice problems, if you turn to that one, I'm going to work this one. This one that has a different equation. And then I'll leave it alone to work the practice problems. So it's asking me how many grams of Fe2O3 are used if 2.88 grams of Fe are produced. So that's what I'm given in the problem. 2.88 grams of Fe is telling me, if I got 2.88 grams of this, how many grams of Fe2O3 were used? So it's a grams problem. It's going to be 3 steps. So my first step, simply convert to moles. I'm given 2.88 grams of Fe. I need to find the number of moles of that. So then 2.88 grams, convert to moles, I divide by the molar mass of Fe. If I look up on the periodic table, the molar mass of Fe is 55.85. Again, I do not use this coefficient right here when I'm converting moles to grams to moles. That's only used in step 2, going from moles of Fe to moles of Fe2O3. I do not multiply my molar mass by 4. That is wrong. I just use the molar mass for Fe. So now 2.88 divided by 55.85 gives me 0.052. So now I'm in moles of Fe. Step number 2, I'm going to go from moles of Fe to moles of Fe2O3 using my Bounce equation. The coefficient for the Fe is 4, so put 4 over 0.052 equals, and I'm looking for Fe2O3, the coefficient for it is a 2, so put 2 over X. So it's a 4:2 ratio. What would that ratio be if I had 0.052? That's what I'm looking for, X. That becomes 4X equals 0.052 times 2. Now divide both sides by 4. My X is going to be 0.052 .026. And that is moles of Fe2O3. But I don't want my answer in moles, I want my answer in grams. So I will take my third step is to do .026 times the molar mass of Fe2O3. If you add up the individual masses of Fe2O3 and find the molar mass, you will get that it is 159.69. So my answer ends up being 4.15 grams of Fe2O3. So what it's saying is if I had 2.88 grams of Fe right here produced, how many grams of Fe2O3 reacted to get that? 4.15. So if somebody told me, hey, I need you to produce 2.88 grams of iron with a reaction, well, I could start with 4.15 grams of Fe2O3 and I should get 2.88 grams. But that's theoretically. It never goes like that in the lab. We'll talk about that later on. Now, there's a way of doing these problems where you multiply everything out without breaking it down into 3 steps. You just multiply everything out. However, in all my years of teaching, when teaching that method of how to do these problems, nobody has ever worked them that way that I know. Everybody prefers to break it down into 3 steps. And when you multiply it out, you know, like the longer way, you have to cancel out units. And for some reason, students don't like to do that. So I've kind of quit teaching it that way. All right, now your assignment is to work the practice problems. And if you don't finish in class, you can finish those in class tomorrow.